Hello. 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 Hello.
Hey Shreks, can you come back? My Bluetooth headset is not working. Just come soon. I don't know what's going on.
That's
Not turn it off.
okay.
Is it this one?
No, please disconnect. Put it. Just put it back. Put it back on the Bluetooth device. Hold on.
Is it this one?
No, don't do anything. Don't do it. Okay, now look. Wait for it. Wait for it. No, cancel, dude. Huh? Cancel, cancel. Cancel that.
This one.
So it's pairing.
Sorry, can you please? This is the one.
Yeah. You sure that's the one?
Mm-hmm.
Try connecting your device.
Mm-hmm.
Can we just use it? Just use this
Hold
one.
on, hold on. Oh, you can see me.
They can. Just says try connecting your device again. I'm just going to turn this one on, okay? Let's just do it. Do this. Just please, just forget that. It's microphone.
Hmm?
It's microphone.
Is this one now?
No, but you have to connect this one now. You remove that.
Mhm.
Yes. Yeah. Now hold this down. Hold this. Hold that. Hold the power button. Just hold it down. Hold it.
Remove background noise. Jesus. Why is this doing on? This is not turning on. Is it charged? Hold on. Okay, this is not charged. Charged.
Power on.
Turn it off. Turn it off. Turn it off. Turn it off.
Bluetooth thing. Yeah. Now turn it. You should see this one.
What? It's
Just give it a minute. Just give it a minute. Just see.
Is this charged?
Yeah. Yeah, that's right.
This one?
I don't know. No, it's this.
Oh,
one.
yeah.
That's one. That's one.
Okay, so. Okay, it's good. Okay.
I don't know if that's the right or left. Like, can you switch?
Yeah, it is. Hello. Can you hear me? Hello. Hello? 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 Okay, I think we can get started. Can you all hear me? It would be good if you can give me some feedback on the chat. I'm monitoring the chat. Okay, great. I got a yes. So I'll get started. Welcome everyone, good evening. Thanks for joining us today. I will be going over loops in Python, specifically loops that use lists and dicts. And the purpose of, the goal for me is to hopefully teach you some best practices for clean code. So who we are, Women Who Code is a global nonprofit dedicated to inspiring women to excel in our tech careers, and being and becoming leaders and role models in the tech industry. We are the DC chapter of this organization, and the link to our meetup site is up here on the slide. I hope you can join, go to the link and look at our future events and join us. If you're interested in, joining our team over our chat messenger, we use Slack, and there's a link to request access to the chat as well. That will allow you to, IM message our group, as well as just, post quick questions on anything Python related that any questions that you may have. We host labs twice a month. So the first lab every month is on the first Wednesday, and it's a beginner lab. The third Wednesday of the month is for intermediate or advanced users. This lab specifically, I'd say, is geared towards beginner Python users. So if you know nothing about what loops are, I hope you do by the end of this lab. And if you do know what loops are, I hope I've taught you a technique or two to better loop over them. So let's go get going. So a little bit about myself. My name is Elvita Lobo. I've worked as a software engineer, specifically an embedded software engineer at Texas Instruments for a good portion of my career. And I am a volunteer lead at the DC Women Who Code DC Python group. You can find me on Slack or on LinkedIn. So this is a picture of me with my two little girls, and as a mom of two in tech, the pandemic has been a little crazy, and I'm sure everybody, in whatever their living and working conditions are right now, is juggling more than they asked for. And so I did want to start by saying, thank you for joining us today, and making some time for learning, investing some time in yourself today. Okay, so let's get started. These are just some housekeeping rules we will follow this evening. Please use Twitch for all your chat questions. So that's, you should see the chat box to the right of your screen on Twitch, on your Twitch browser. Now to get started, I've sent a copy of the Colab notebook. Let me just share it again in the chat for those who may have joined late. I don't know if you see a history of the chat, but I'll send it out again. So what you want to do is click on this link and then save a copy of the Colab notebook to your Google Drive. So you can say save a copy in Drive, click on File, save a copy in Drive, and that will allow you to create like your own local copy of this Python notebook that we will use for the lab today. So I'll give you a minute to do that. Okay. Oh, sorry. Okay. The next thing I wanted to show you about Colab is, if you click this Run button, please don't do anything right now, or you can actually do it in your local notebook if you've already created that. But if you click this Run button, you should be able to run a snippet of code, right? So I can do it for, one of as an example. So if I click Run here, I can see this code executed in the little window below, right? So that's one thing. And then through the lab, what I'd like you to do is, sorry, okay. So through the lab, I'd like you to, you just see this little, sorry. Yeah, through the lab, I'd like you to create your own copy of this code snippet and then run that. You can edit it and play around with it. So that gives you, a way to keep the original code snippet as is, and then make a copy and then edit that copy, delete it if you want later, or, so you have the original and a copy that you have a sandbox that you're playing around in. So I can show you how to do that as well. So this kind of threw me off. I remember when the first time I attended a lab with Colab. So what you do is you kind of hover around the center of your snippet and then say plus code, which will add a code block. And then you can just copy whatever you want into this block, right? And then now you have your own sandbox. So now I can, make some changes, run this new code block. So that's how I'd like you to follow along. I'm just deleting that sandbox I created right now. But, ideally you want to have a good working copy of the code and then a copy that you can use to play with. Okay. So far so good. It's so weird. This is my first time doing this thing, and so it's like I'm talking into a void. I have no audio feedback, and all I have is your chat. So if we are good, if most folks are good with what we have so far, you have your copy of Colab up and running. You know how to navigate around it. Just please say yes, we're good, or some feedback so I can proceed. I'll wait for a second or a couple of minutes, a minute. Okay, great. So anybody struggling? We have some TAs also. Sorry, I forgot to introduce my TAs. I think we have Stephanie, Anastasia, I think is also on. I'm not sure who else, but maybe they can say hi now in the chat as well. Hi, Stephanie. Hi, Anastasia. Okay, cool. So I think that's good. We'll get started. We'll go over what our goals for today are. Okay, so as I said before, learn one new thing about loops. If you didn't know about loops, learn what loops are. If you knew what loops are, just one new strategy to make your loops better. And then ideally, what I'd like you to do is just go back to a code base. If you have something at work or something you're playing with, or if you don't have anything, just go to GitHub, clone something, and then with what you've learned, find one thing you can fix. Just use a basic search and replace to make the code either cleaner or more efficient, right? That would be a successful evening, right? Whenever I attend a talk, that's about all my goal is just learn one new thing. If I picked it up right then and there, great. If I learn or I overhear something in the talk that I never heard before, I try to learn it right then and there. So in your case, use the chat, clarify, ask the clarifying question. And if even that's not possible, that's fine. Write it down and just look it up later. That's basically what we're trying to get to, one new thing today. Cool. Okay, so let's get started. What are loops, right? Loops are a programming structure that basically repeats a sequence of instructions until a condition is met. If you've baked a cake or followed any recipe, an example would be one cup of flour, add 1 cup of flour, 1 cup of oil, and then crack 4 eggs and add the 4 eggs, right? So in your recipe could read like that, or it could read add the first egg, add the second egg, add the third egg, and add the fourth egg. So you're doing that repetitive sort of motion of crack the egg, add it to your ingredients, or bowl, mixing bowl, crack the egg, add it to the mixing bowl, crack the egg, add it to the mixing bowl. You can just say, do that 4 times, right? That's a loop. So in this example, basically your specific condition is crack and add eggs until you have no more eggs, with the assumption that you specified a number of eggs equal 4 somewhere at the top, right? So crack and add eggs until you have no more eggs left. So that's the specific condition for exiting your loop, being done, right? So I just decreased my recipe by 4 lines there. Instead of 4 lines, I had 1 line, so I could reduce code size, right? Instead of saying the same thing 4 times, I just said it once. Great. Readability, when you have the same thing repeated 4 times, people start to squint and say, oh, I just want to make sure nothing was changed in between the lines, right? It becomes hard to read. You want to make sure you're doing the same thing and you're not doing different things. It's just easier to read your code. And then reduce errors, right? You want to make sure you're doing the same thing and not sort of, there's no different steps sort of creeping in each iteration of the loop, right? So those are the advantages of loops. Now, what are the downsides, right? Corner cases, right? A great example of corner cases is Python itself, where the way to specify the end of a loop is, you can say range, and then you can say your sort of end is 4, right? So give me numbers from 0 to 4. When you say that in Python, when you say 4, Python actually stops at 3, right? So your loop actually, if you say loop up to 4, in Python, when you, and we'll go over this specifically, so don't worry if you don't follow me right now, but if you say loop up to 4 in Python, what Python will give you back is 0, 1, 2, and 3. So you have to make sure you understand your start and stop condition clearly, and you're expressing it clearly in the language. So that's what I meant by corner cases here. Infinite loops. Every now and then you'll have code that just hangs, right? You're stuck in an infinite loop, and going back to my egg example, if the algorithm was, or the for loop said, basically, crack open, take an egg and crack it open, and with every iteration, if you added an egg, right, into your basket, your end condition, the specific condition for exiting the loop will never be met, right? Because you just said, for every egg you have in the basket, take it, crack it open, and throw it into your mixing bowl until you have no more eggs left in your basket. But if you're adding an egg with every iteration, you just keep going, and you're in an infinite loop, right? So you want to be careful that you're not updating your exit criteria while you're in the loop, or you may get stuck in this kind of condition. Cost. Loops can get expensive very easily, right? You can just say, do this 100 times or do this 1,000,000 times. And if this is something not so smart, then you're doing a not so smart thing 1,000,000 times, right? And when I say smart, what I mean is it's basically, processor cycles, right? It's CPU cycles. If you think of, or memory, right? When you buy a computer, you get a processor and it says, oh, it's a 3 gigahertz processor, right? Or it has, 8 GB of RAM, right? Think of those two things, the RAM, the memory that your computer has, or your processor speed as piles of money, right? Dollar bills, piles of dollar bills, right? So if you have a loop that requires 4 processor cycles, right? Then 4 of those dollar bills are gone to going through one pass of that loop. Now, if you run that loop 1,000,000 times, you need $4 million bills to pay for that, right? That's performance you're paying for. So a lot of times actually algorithms are basically if you have these code to do things like Google search algorithm, they are judged by the loops in them, the number of loops in them. Cost is a very important factor of loops, and it becomes a deciding piece of how many loops you have. Are they nested? Because those very quickly increase the cost of your program. Okay. So everyone with me so far? Any questions about what loops are? Yes, so good question. Will you get all the dollar bills back once the loop ends? Yes, because yes, it's not money you throw away. It's money you throw at, and then your loop has ended. So your processor is not spending any more money on that. So you got everything back, and now it can spend it on something else. Yes, so you do get your dollar bills back, right? So if you closed all the programs on your PC, right? And then you looked at memory utilization or CPU utilization, you should see, you know, very like 1% or 2%. If you opened up a bunch of programs, you should see, and that did a lot of like, you know, you had, I'm streaming live videos. If I look at my CPU utilization right now, it'll be a lot. As soon as I close my streaming service, you know, it'll go back to not being very much, and it's available to spend across other programs. Good question. Okay. Any other questions about what loops are, or any of the, you know, pros and cons of that I listed here? Okay. Okay, so things to keep in mind. Flat is better than nested, the Zen of Python. I wanted to actually show you this in case you don't know what I'm talking about when I say the Zen of Python, because it's kind of cool. If you ran this, and I just have some, you know, temporary Python notebook open here. If you just said import this, and then you ran import this. Not sure what happened there. Let's see if I can try again. Why am I unable to run any code? Yeah, this works. Okay, let me just try this. Just humor me for a little bit. I'll try this here because this notebook seems to be working. No. Oh, that's too bad. Let me see if I can do this in my okay, cool. I have a, can you see, I have a Python, my Python ID available here, and all I did was import this. I don't know why it didn't work in my Python notebook. I tried it earlier and it did work, but I just said import this and then I ran it. And you'll see the Zen of Python by Tim Peters. It's just like philosophy about, you know, how to write code, right? And that's kind of like a guiding principle of my talk, so I thought I'd introduce you to it. Beautiful is better than ugly, of course. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Flat is better than nested. Right, and this is very important when we talk about loops, right? It's easy to start nesting loops. When I say nesting, you know, think of a lot of indented code, and you know, when you just pull it up and you look at these indentations, you're like, oh my gosh, right? Flat is better than nested. Yeah, so that's in the Zen of Python, and you want to keep your code, you know, looking clean. Not being intimidating, right? Another thing to keep in mind is don't add or remove items in a list while looping over it. Kind of gave you that egg analogy, right? Your exit criteria is when all your eggs are used up, but with every iteration you keep adding an egg, you'll never get out of the loop, right? You want to make a copy and then change the copy. Then you know, you can sort of, you can change the properties of an item, so you could edit an item in that sense. But if you're adding or removing items, then that you know, it's like a state of sin. You don't want to go there, right? Try to use inbuilt functions in the language instead of writing explicit groups. So you know, this kind of ties into number one. Python has a bunch of inbuilt functions in the language, and you know, try to use those instead of saying for, you know, instead of writing explicit loops. There's a lot of inbuilt functions in Python that you can use to just do stuff, and we'll go over this. So this is the focus of the lab. I don't want to go too much into detail of this because it's a little bit of an advanced topic, but if you're trying to process big data, loops are bad. You know, you don't want to do that. You want to use vectorization. Vectorization basically, instead of you know, going over a list of numbers from 1 to 100, say, you put them in an array, and then so say you are trying to add two lists of numbers. Each list has 100 entries, right? You want to put them in an array and then just add the two arrays up. The reason for this is, you know, your CPU, your hardware is just handles that better and more efficiently than you could ever writing a for loop to do that, right? So just use vectorization there. Okay, so before I go on to the next slide, any questions about this? I hope you all can check out the Zen of Python later if you haven't already or you didn't know about that. Can you still hear me? Okay, cool. Thanks, Stephanie. Cool. Okay, so I think we're ready to go to Colab, and there's a list of resources, and I think that's all I got. So yeah, let's move over to Colab. Here's my Colab. I have a lag for the comments between the video and the audio, you mean? Oh, that's too bad. Oh, okay. Thanks. I'll try to just go slower, I guess, and pause for catch up. Okay. Yeah, I'm not sure what I can do about that right now. Oh, okay. Okay. That's probably not as bad. Okay. Thanks, Stephanie. Okay, so everyone in Colab, by the way, this lab is intended to cover the material published in Raymond Hettinger's talk, Transforming Code into Beautiful Idiomatic Python, PyCon 2013. I put a link to the talk here, I put a link to the talk at the bottom. There's two talks that I would really, really highly recommend. I've, viewed them multiple times every time I pick up something new. It's the mental game of Python and transforming code into beautiful idiomatic Python. I follow him on Twitter. He's a Python core developer and is a very good teacher. So I think sometimes I'll read something online and I still can't follow it. But when somebody teaches you well on a video, it's like nothing can beat that. So here's the links to the talk. And so basically, I converted the talk into a lab, and that's what we will go over today. Right? There's always two conflicting rules of writing clean code, right? Don't put too much on a line. Don't try to do like 10 things with one line of code, because then you're back into that same thing of, oh, what is this person trying to say with this line of code? What are they trying to do with this one line of code? But at the same time, don't break atoms of thought into subatomic particles. So if you want to convey one thought, don't write 20 lines to convey that one thought, because again, then that's not clean. So these are like two sort of conflicting, driving you in opposite direction kind of rules on writing clean code, right? Raymond simplifies it. He says, one logical line of code should be one sentence in English. If you were to say, give me the smallest element in this list, right? That should be one line of Python, right? So using that as the background, we can start with our lab. So let's start with a simple example, right? Here I have a list of 6 integers, 0 to 5, 0, 1, 2, 3, 4, 5, and I want to print the squares of these numbers, right? So what I did is I basically created this list. So I explicitly said 0, 1, 2, 3, 4, 5, and then I said print I square. So in Python, the star is multiplication, and then 2 stars is raised to the power of, so I square. So this will print 0 squared, then 1 squared, 2 squared, 3 squared, 4 squared, and then 5 squared, right? So let's see if that works. Yes, so you have 0, 1, 4, 9, 16, 25, right? So this allows me to loop over this range. So I'm going to stop and allow you to, put this in your sandbox, run it, maybe modify that list, and when you're done, maybe you can send me a couple of yeses on the chat, and we'll move on to the next example. Okay. Cool. Very good. Okay. Now, what if I wanted to, so we'll move on. I got a couple yeses. What if I wanted to print numbers from 0 to 9, but instead of going, one step, increments of 1, I wanted to do increments of 2. So, skip every alternate number. Now, here's the corner case thing that I previously mentioned, right? When I say 0 to 9, Python's going to go from 0 to 8. It's going to stop 1 before my stop value, right? So the syntax for this is the start, stop, and this is the step size. So in this case, it's going to go 0, then 2, then 4, 6, 8, and then it's going to stop there because my stop is 9. It's going to stop 1 before my stop value. So we can run this, and there you go, 0, 2, 4, 6, 8. I didn't print I squared, I printed I, so you're just getting the numbers as is. So I'll wait for you to run that, copy it, edit, and when you're done, put a yes in the chat. Cool. Okay. Let's go on to the next one. So this one's a little more concise, right? I don't need to, if I'm using default values, Python default values for some of these parameters, I don't need to specify them. So here I want to again print squares of the numbers, and what I'm doing here is I'm not specifying a start and I'm not specifying a step, right? So basically I'm going from 0 to 5, right? And I'm going in increments of 1. So I can just say range 6. So here's where you need to be careful. Always remember Python, it's stopping 1 before what you actually specify. So you're going from 0 to 5 and then in increments of 1. And then here you get, similar to what we had initially done, 0, 1, 2, 3, 4, 5, instead of, actually specifying this, you're just saying range 6, right? Okay, so I see a question. If you only give one input to range, it correlates to the stop, and the defaults are start of 1 and step of 1. Yeah. So for your first question, does it correlate to the stop? That's right, it correlates to the stop, but the default start is 0. So that's another corner case that got you there, right? So it's going from a start of 0 and a step of 1. Yeah, so computers don't start at 1, they start at 0, and that always trips me up as well. Okay, cool. So one quick tidbit here, if you don't get it, this is something you can write down and Google later, but it's just a little tidbit. So between Python 2 and Python 3, there's a difference in how range was implemented. In Python 2, you had a function called xrange. And what xrange would do is, let me tell you what range did in Python 2. What range did in Python 2 is, if you said range 6, it would create this list of 0 to 5, just like we had here. It would create this in memory, bring that whole list into memory, and then start doing whatever you needed to do in the loop, right? But Python 2 had another function called xrange. And xrange would not do all this upfront work. It would just generate the numbers that it needed to on the fly. So it was sort of bringing 0 into memory, running through the loop, bringing 1 into memory, running through the loop, getting 2 into the memory, running through the loop. So it was more efficient, especially for larger numbers, and if you needed to do it multiple times, right? And so that was Python 2. And in Python 3, they said, this guy's so efficient, xrange is so efficient, let's just get rid of range. And, they just they made xrange range. They made it the default behavior in Python 3. So it's just a more efficient version of, Python, of the range function that we had in Python 2. So I'm using Python 3 here, but I could have shown you, but if you have Python 2, you can use this timeIt function. There's a timeIt function in Python that you can use to time how much it takes to, how much time it takes to run any Python instruction. And you can use timeIt on range and xrange, and you can see that xrange is faster than range. But you don't need to care about this if you're using Python 3, which you should be, because it's just you just get the more efficient version for free. Okay, looping over collection. So now I'll have a list, instead of integers or numbers, I have a list of strings. They're names of 4 people I know: Alice, Dan, Caroline, and Ben. And I want to print all the names I have in this list, right? So what I'm going to say here is, for I in range length of names. So length of names basically gives me the size of this list, right? So I have, the size here is 1, 2, 3, 4. It has 4 elements, so the size will be 4, right? And so I in range 4. So that gives me, I will evaluate to 0, 1, 2, and 3, right? and then I say print name 0. So print name 0 will give me Alice. Print name 1 will give me Dan. Print name 2 will give me Caroline. And print name 3 will give me Ben. So the index goes from 0, 1, 2, 3. Right? So that's how this works. So it will evaluate what, I'm giving it kind of a little formula it needs to evaluate this, because then I can, you know, add another name and it will still work, right? So I can say, give me the length, and then I use that to calculate my stop value. And then once I have that stop value, it's kind of what I did here, you know, with the range 6. So here it would be I in range 4, and then I print, go over each element and print. So I'll give you a second to do this in your sandbox, and give me some feedback when it's okay to proceed. Okay, so let's move on. So there's a better way to do this, right? Similar to what Raymond's advice was, you know, make it like a sentence in English. For name in names, just print the name, right? If I had to explain this to a 5-year-old versus explaining this to a 5-year-old, this one's much easier, right? Simple is better than complex, I guess. So for name and names, just print name, right? That works as well. Right, so I get my list of names. Okay. Looping using index and value. Cool, thank you. I got a yes, so I'll use that to proceed. So looping over a collection using index and value. Now sometimes you want to know the value of the index. You want to know what position that particular value was in the list. So this is at the 0th position, Alice is at the 0th position, Dan is at the 1st, Caroline is 2nd, Ben is 3. You want to, for some reason, you know, whatever reason, know what that value is, right? So you could do it this way, where you could say, here you have I, and then you have names I, right? But that's still, it's hard on the eyes to read, right? You can use enumerate. Enumerate works for, you know, all the different Python data structures, right? List, dix. What enumerate does is basically gives you the values along with the index, right? So here it'll give you the 0th index, and then it'll give you the actual value, the name. So you have to specify, for if you're using enumerate, you have to specify 2 variables. You have to say what you want your index to be called and what you want the value to be called, and then it will give you the index number and it will give you the value. So in this case, you'll get 0 Alice, 1 Dan, 2 Caroline, 3 Ben. Okay. Say we wanted to loop backwards. We wanted to go from Ben to Alice, right? How do I do that? My start has to be the last element. My stop has to be the first element, and I have to say go in increments of, stepping back, right? So, so my start has to be, in this case, length will return 4. So 4 minus 1 is 3. So that's the index I want to start at, 3. I want to go up to minus 1. So the reason I go up to minus 1 is, remember, Python stops at 1 before the stop value. So 1 before on the number line, imagine the number line, you have minus 1. The number to the right of minus 1 is 0, right? So 1 before minus 1 is 0. That's your stop value. And then increments of minus 1 will just basically decrement your value of I. So it will go from 3. 3 minus 1 is 2, minus 1 is 1, and then minus 1 is 0. So the question is, good question. You must know, do you need to know the length of the list ahead of time for this to work? You don't need to, because, this function, this length function, will calculate it on the fly for you. So if I had, if I just added Elvita to the list, this would still work, right? I didn't have to change anything in my loop to get this to work. I hope that answers your question. If it didn't, please follow up. Okay. Right, so I hope this was not, I'm sure this was confusing actually, because it took me, although I wrote this up, it took me a while to all the minus ones and all that was like, oh my gosh, I don't know what's happening here. And for somebody who doesn't know Python actually, they may not even be able to get to this without Stack Overflow, like Googling what the hell this loop does, right? There's an easier way, better. Beautiful is better than ugly, reversed, right? It just gives you the list in reversed. So one sentence of English, one line of Python for name in reversed, print name. Okay. Okay, how's everyone doing? Need a break, need a stretch? Okay, so looping in sorted order. What if, okay, good to know that this is helpful. That's really great. Looping in sorted order. So what if I wanted to print the names in sorted order of the first alphabet of the name? So in this case, we have 4 names and they start with A, D, C, and B. What if I wanted to print Alice starting with A and then B, Ben, C, Caroline, and D, Dan, right? In forward sorted ascending order of, ascending alphabetical order of their names. I just say sorted again. Sorted will basically sort on basically sort on the ASCII code of this first letter, and I'll go over that in a little bit, where I'll give you an example where this breaks and I'll show you why it broke, right? But basically every key, everything that you type on your keyboard is has a specific code, and you can look this up, ASCII code table. It has a specific code. So the letter A has a specific code, B has a specific code. So this just takes that first letter, looks up the code, and then the code is a number basically. So all these just translate to a number. and then it will just sort the numbers it got, for A, D, C, and B, sort them in ascending order, and it just happens that the codes, of course, thankfully, for A, B, C, D are in ascending order. They come one after the other in the ASCII table, and so you'll get, Alice, Ben, Caroline, and Dan. Okay. Now, what if I wanted to print it in backward sorted order? So if I wanted D, C, B, A, Dan, Caroline, Ben, and Alice, I just there's a parameter, there's this reverse equal true that you can pass to sorted, the sorted function, and this is kind of it goes back to what I said about using inbuilt functions instead of trying to do this yourself. You could write code to do this exact same thing like we were trying to do here, with the minus ones. I forget where that was. Yeah, this one. The minus ones, we can write code to do this, or we can use inbuilt functions. So use the inbuilt functions. There's always an inbuilt function in Python. There's always a library available in Python. Don't try to reinvent the wheel. Just use the function. It's efficient. It's easier to read, right? So you can say reverse true. Now, if I didn't know Python, I could come here and see this one sentence, sort in reverse order. I could read this and know what it's doing, right? That's the beauty of it. So here I can now get Dan, Caroline, Ben, and Alice backwards sorted order. Okay. Sorting in alphabetical order, sorry. What if I had uppercase D, right? And I say now sort it, just like I did previously, right? All I've done here is basically change this Dan D to a uppercase D. What would I get here? The ASCII value, the number value in the table for D is 68, and for A is 97. So Python, just looks at the first letter, computes its ASCII value, and then sorts. So in this case, D comes before A. And yes, I get Dan before Alice, right? Not what I wanted. I don't know. Somebody entered, all the names with a lowercase, but just one name with an uppercase, and now I can't sort anymore correctly, right? So what do we do here? There is another argument you can give to the sorted function called key. So you can say key equal string.lower. What this does is basically take every element. So the way this works is you specify what you want to do with each value before you sort, right? So here what I'm saying is convert everything to lowercase and then sort, right? So the key argument expects a function to be passed to it, and that function will be used on each value in the list to determine the order that sorted will sort in, right? But the original values are not changed in the input or the output. It just uses that to compute the sorting order but you will see the original values just stay the same, the original values in the input. So here it will convert the D to lowercase, and then you get back that same order and then print it. So when you print it now, Dan is actually where it needs to be, and it's still uppercase. It has not changed Dan to lowercase. It just did that when before it computed the order for sorting. Any questions so far? I think we've covered quite a bit, and I want to make sure everyone's with me, or at least kind of getting a sense of what we're doing. Okay. So just like I passed a function to lower, okay. Oh, that's very interesting. Somebody shared their workplace an IT service management software that's extremely picky about capital letters in people's names, the exact formats of phone numbers. And I feel like if they made tiny changes like this to their search format, it would prevent a little bit of chaos. Haha. Yes, agree. And that's, I think, kind of what I was thinking of when I said go back to your code base and do a little search replace. It's funny how something I guess it's very easy to, when you're programming, you kind of go with a certain mindset, and that's what like unit tests and integration tests, unit tests really are for, because you want to, put these, I wouldn't even say corner cases, but like these odd cases, negative cases, put your code through those, so somebody didn't unit test well. Okay, so sort by length. So you can also, the key is basically, the function that you pass to sort it, right? So here we said make everything lowercase before you sort. Here what we're saying is calculate the length and use that to sort. So then again, this will give me from shortest word to the longest word in number of characters in the word, because I'm saying sort by the length of the word. So here I'll get, now will I get Dan first or Ben first? Let's see. I get Dan first, so that's good. This kind of sorting is called, I think it's called like stable sort, where you have two values of the same, two elements of the same value, so it could put either, but it preserves the value that the data was presented in. So that's always a good thing for sorting. If two values are the same, you preserve the order that you got the data in. So Dan, Ben, Alice, and Caroline. Okay, so that was looping over lists. We'll go over looping over dicts. I don't know how I'm doing on time. I think we have until 8. And that's fine. What I want to get to is the lab, and then I have 2 examples showing, using all this in a more complex situation, more real life situation. And so even if we don't get time to go over those, I think that's fine. I'd like to just go over these little examples that we have so that you get the basics, solid. Oh, thank you. I have until 8:30. Although I don't know if I should go until 8:30. That would probably make some people mad. Okay, thanks. Could you nest sorts? For instance, if you wanted to alphabetize and then sort by length, resulting in Ben coming before Dan. I see. So if you wanted Ben to come before Dan, you would do yeah, so basically you want to pass two functions to sort. That's a good question. Yeah, so what you would want to do then is kind of make a copy of your thing. Yeah, so you do sorted twice. So you just run sorted with by key equal string dot lower, and then you save that into a list, and then you run sorted again on that saved copy, and you pass key equal length, and then you can do that. Or yeah, that's a good, but you have to write a lambda function or a standalone function. Yeah, yeah, you could. I don't know what that lambda would look like. But you can always run it twice if making a copy is not when you're making a copy you're using more memory, so that's sometimes frowned upon. But yeah, sort twice is I would say the more readable way. And there's always multiple ways to do things, yeah. And there's always a stack of overflow answer to your question. So, if you can't find that, I'm happy to look into it for you. That's why you should chat me up on Slack, I guess, if you still don't get that. Okay? You can make a note of that, because that's interesting to me as well as other twice. Okay. So looping over dictionaries, we'll first look over looping, how to loop over dict keys, right? So here I want to print, so I want to loop over this dictionary. Okay, so Anastasia has a example, so I'll let you try that out. Cool, thanks Anastasia. Okay, so looping over dict keys, so these are in a dictionary, it's a key value, basically a set of key value pairs, right? So this is the key, this is the value. So I have the same characters, Alice, Dan, Caroline, and Ben, and they're each assigned a color. That's the value of the keys in this dict, right? I want to print all the names, so I want to print all the keys. I can just say for K in D, print K. This is cool, right? So if I just say loop over my dict, I get the keys basically. I can also say, for K in list D dot keys, print print D. Print K. That will give me all the keys. I kind of prefer D dot keys. It's just more explicit. Explicit is better than implicit, because if I didn't know Python, I would not know what this was doing, right? So here it's returning a list, and then it's iterating over that list. D dot keys makes a copy of the keys and stores them in a list. So actually, when you get this copy, you can actually modify it, but this is something you should never do, by the way, because if you mutate something while you're iterating over it, not a good idea, right? You can do this because you've made a copy now of the dictionary, so you're not your loop will work, but it's still not a good practice. So here, Caroline is deleted. I went over each key, and then if the key was equal to Caroline, I said delete that. So it allowed me to do that. I think if you try to do it here for K and D, and if K equals Caroline, delete, it would not even allow you to do that. It's just not a good practice. What I'm trying to just say here is that you can do this by making a copy of the keys using this d.keys function. Okay, all good so far? We still have a few folks that are following, or everybody's just like given up too long? Yeah, I think we just have a few more, and I can go over these pretty quickly. They're not that difficult. It's basically the same concept, but just doing it on digs. So looping, if I wanted keys and values, what would I do? I could say for K and D, which will give me the keys, print the key and then show me the value. This is kind of like how we did it in lists, where we said, give me the name of the list and then the index value, right? It's kind of like that. So K and then D of K. Better still, not so good to read, for key K comma V for keys and values in d.items. D.items gives me both the keys and values. Kind of like, I wouldn't compare it with an enumerate, but basically it will give me both the key and value, and then I can print K and V. And so here, I get the keys and then the values on the other side. So I'll give you a minute. Please send me feedback on how you're doing. Give you a minute to play with these examples. Will you post a recording? I believe so. I think the answer is yes. I'll let one of the moderators tell me about the recording. I know it's saved somewhere. I just don't know where it's uploaded to. But I'll take a note of that and post it on the meetup page if we don't get an answer right away. Okay, so counting with digs, right? Digs are actually very, very useful in Python. There's another Raymond Hettinger video about digs, and I strongly recommend you to watch it. It just shows you how digs are implemented. This simple example here, right? We have a list of colors, and I want to count how many reds, how many greens, how many blues, right? So D equals, I'm declaring my dict, and what I'm going to say is for each key, for each color, so the color will be the key, and the value will be the number of times it occurs in this list, right? So I want a dict which basically says red 3, green 2, blue 1, right? So the way to do that is I go for color in colors. That's some technique I learned up there for color in colors. If the color is not in my, if this key is not in my dict, then create this value, right? So create a key and assign it the value 0. If it is in my dict, then I just access it, and basically I'm incrementing whatever value is in there by 1, right? So basically I came across another instance of that color, take whatever value I have and increment it by 1, right? With me so far? It's just a simple way of If you don't have the value, create it. If you have the value, take it and increment it, right? That's what these two lines are doing. Cool. What's better? What could be better in this? One line in English, basically just increment the value, right? If the value is 0, just increment it, one line in English. For color in colors, access this D color. Now if it does not exist, right? So this is the key here, D.get, right? So D.get will basically get the value that's stored for this key, right? And if the key does not exist, it will return this next parameter, which is 0, right? So get the value for this color. If it does not exist, if that color does not exist in my dict, return 0, and then just increment it. One line, much easier. This is definitely a search and replace in your code base. One of those things that, like, I as a beginner always wrote this way, and then I was like, oh wow, there's an easier way to do this. And so this will give me red 3, green 2, blue 1, right? So this is definitely one I've used. And I think there's more advanced ways of doing this, but for this video, I think this is good, but you can definitely look at more advanced ways. And the cool thing is it allows you to set a default also here, right? In that one line. Okay. Updating multiple state variables. So this is nothing to do with loops, okay? But sometimes in a loop, you have to update multiple variables, right? And you want to do it updating all those variables close to each other, because the reason you want to do it close to each other is because there's this concept of threads in any language, I mean just threading. If your application is single threaded, that means there's only one line of control through the whole thing. That's great. You don't care so much about where these variables are getting updated. But suppose 5 years from now they say, okay, we have to make this multi-threaded because we need to do so many other things with this one application, and they make it multi-threaded. And then what happens there is you update one variable, and then you have multiple threads running, in parallel, and the processor basically switches from that thread to another thread, and basically that thread, updates another variable, and then, you're messed up for whatever reason. I won't go too much into that detail. It's a kind of beyond the scope of this. But basically, when you're updating variables in a loop, you want to do it sort of close to each other. And the reason for that is if you have a multi-threaded application, you can your variables can get into a stale state, right? So a simple example. Forget about threads. I said all that if you didn't follow it through. A simple example of Fibonacci, right? In Fibonacci series is basically a series of numbers where every number is the sum of its previous two numbers. So the first two numbers are a given, 0 and 1. You always start the Fibonacci with 0 and 1. The third Fibonacci number is the sum of 0 and 1, so it's 1. The fourth Fibonacci number is the sum of 1 and 1, so it's 2, right? So each subsequent number is basically the sum of its previous two numbers. So how would I calculate this Fibonacci series, right? If I want to calculate the third Fibonacci number, right? What I do is, I store the previous number in a temp variable, right? Then I update that y, that previous number, with the sum of the previous two. And then I take that temp variable and put it in x, right? So x and y are my two numbers. And I'm basically, saving previous number because it's still valid. Then I add up, and then I throw away this number. I basically now have my next number, and then I have the previous number, right? We are not going to run this code because it's just a very simple example. The easier way to do it is just this. It's like one sentence of English, right? Take y, put it in x, and then take x plus y and put it in y. It's done in one line. This whole piece of code is basically replaced by just exactly what you want, right? Basically, if you have two numbers in the sequence, you want to make this number the sum of the previous two, and then your pointer gets moved over to the next to point to the first number there. I don't know if this was very clear, but you can look up Fibonacci, and when you look at this code, you kind of get what we're trying to do here. Okay, concatenating strings. So concatenating strings, just another thing, you'll find sometimes in a loop, if I just wanted to print Alice, Dan, Caroline, and Ben in one line, I could say for name so I assign I take a string and I assign it the first word. And then for every subsequent word, I start at 1, right, index 1. I just use this plus operator to concatenate. This is good, but it's very, very inefficient. Please don't ever do this in a loop. You want to use join. The reason you don't want to do it in a loop is basically when you're doing this, every time Python is in the loop, it's like allocating memory for this new string that you're trying to create, right? So in this case, it's like allocating memory 4 times. So it's just not efficient. Here, it just allocates it once for everything that you want to concatenate. So you don't have those extra 3 allocations, like in this case. Okay, so how are we doing? Cool. Okay, so I think this is the last concept I'll introduce to you, and I think I'll stop here. I have 2 examples. And you can go over them, but we'll basically, I'll stop talking at this point and you can play with the examples. And if you have any questions, I'll hang around for some time and you can post them in chat, right? This is just a handy visual for you to sort of go between these islands of different Python data structures, right? You have ints, you have strings, you have files, lists, set, ticks, right? And if you, many a times, to achieve what you're trying to achieve, you have to sort of kind of go between these different Python data structures. And this just gives you the appropriate function you need to use to kind of switch between those, right? So the way I kind of presented this is, actually the way Raymond Hedinger presents this in his talk is, with this Kapraker constant. It's basically, I didn't know this, but if you take any 4-digit number and you create the largest number you can create. So if you have 3524, the largest number would be putting 5 in the most significant digit, 5432, that would be the largest number I could create with this, these 4 numbers. And then you subtract the smallest number that you could create from it. So in this case, the 2, the smallest number, will be in the most significant spot. And so 2, 3, 4, 5, right? And then you get 3087. And then if you keep doing this, so for 3087, you do 870, 30, 0378, You keep doing this, you'll always reach this constant 6174. Okay. Somebody said, I didn't know of join as an alternative to concatenating. That was great. Yeah, I would say, yeah, the opposite, where concatenating is the alternative to join, because, and I didn't know about, you know, the memory implications of this either, and I was shocked at how many pluses I had a lot of code like this, believe me, in what I was writing. I just use this for debug all the time. But yeah, join, you want to use join. Okay, sorry, I switched. Yeah, so the Capricorn constant, right? So you basically want to, you know, you're given a set of numbers, you want to sort it in descending order, right? And then you get the largest number that you can create from it. Then you want to sort it in ascending order, so you get the smallest number that you create from it, and then you want to subtract those. Very simple, right, to say it in English, right? How do you code this? And if you try to do this in other languages, it's a lot of code. In Python, you know, I'll go back to this picture. Let me see if I can decrease the font so you can see the example while you have the image here. So in Python, I'm on the island of ints. That's how Raymond explains this, right? And now I want to sort. So to sort, I want to go to the island of lists, because that's where I have the sort function, right? So to get to the island of lists, I need to take a connecting flight through the island of strings, right? So I use format to get to strings, right? And then I use either list or split to get to lists, right? So that's what I'm doing in this code here. I'm using format. So I'm taking, this is a function that basically does, you know, does this once. Basically find the biggest number, find the smallest number, subtract the two, right? So it formats it. So this is converting the number into a string, right? So now I have 3524, that integer is now a string. And then I say list. So now it's, you know, I've come from here to the island of lists, right? So now I have a list basically that looks like, you know, if I took 3524, it would be 3524, right? And now I say sort. Let me actually, so this will be, what is it? 3524, yeah. So this is what I get at this, 3524. And then I get a list, and then I say sort. So here I have to, oh, and I'm saying sort reverse equal true, right? So I go 5, 4, 3, 2, right? And now ignore the int part, just focus on what's in here. Dot join t. So now I'm going from the island of list to the island of string, right? So now I have 5432, right? And now I am going from, with this int, right? With this int, I'm going from taking the flight from string to int with int, right? So 5432, and then I have the actual integer 5432, right? This is what the part in the parenthesis gives me, and then this is what I get from the whole statement, 5432, big equal 5432. Now I still have, t is still on the island of lists, right? So t is still here. So I can say t dot sort, and this will just sort in ascending order, and this will give me, on the island of lists, it will give me this. And then I do the same thing, and I get 2, 3, 4, 5, right? So I get the little number, and now I can just say big minus little and return that. So you can actually run this code, and you get 6174. Oh, sorry, I'm getting 6174 because I'm doing it on this. If I do 3524, sorry, I will get 3087, which is the first iteration of this example. So yeah, definitely play around with this, and I think we will stop here. I'll quickly go over what this is doing, but I won't go over the code. You can look at the code and look at it yourself. But I'd like to just spend the rest of the time we have answering any questions in relation to this, if you have any. The link to where he explains this, Raymond Hedinka explains this, is here. This is an image, so you can also find it here in Mental Game of Python. This is the same link. He explains this example. Okay. Cool. Yeah, I have printed this out and it's on my whiteboard or my board at home, so I can, I still read. Every now and then I'll be in a situation where I have to be like, how do I get from here to there? Okay. So longest common prefix, I was looking for examples that would kind of exercise the strategies we've learned, right? And I found one on LeetCode, and I found some pretty clever. So the first one is kind of my first stab at it, and then I found a better and a questionable better implementation of this, right? So the question was, write a function to find the longest common prefix string amongst an array of strings, right? If there's no common prefix, return an empty string. So you have three strings here, flower, flow, and flight. And I want to see the longest common prefix. So, I have F here, I have F here, F here. Cool. So F goes in my answer. And then I have L, L, L. Cool. L goes in. O, O, but I have I here, so that's not a common prefix, so I have to stop there, right? So I start with the first letter, and then I check every word in my array, in my list, to ensure I have they match, and if they don't match, I have to return whatever I have so far. In this case, dog, race, car, D, R, C, nothing matches. I'll put an empty string. So I'm going to go over this quickly. Basically, my idea was, give me the shortest word here, right? And then for that word, I'll go character by character and compare every character with what I have in the list. And if there's a match, I put it in my answer. If there isn't a match, then, or in my return variable, if there isn't a match, I return what I have in my return variable so far, right? So I tried to do, say, sorted, and I said sorted and give me the first element of the sorted array, right? Because that will be the smallest word I have. And then I said, go over each of the characters in this smallest string I found, and then find for match, look for matches, and go to see, there is a better way to do it, right? Instead of sorting and then looking at the first word, I can just say min, and min, just like sorted, takes key length. So it will basically sort it by length and then return the minimum value. I fell into the trap of going I in range length. Instead of that, I can just say enumerate, and then I don't have to say smallest string I can just say ch instead. So I'm using I and I'm using the value. I can just use enumerate to make my code look simpler. And then maybe in part 2 of this lab, we can go over more advanced, functions in Python, like we did enumerate, but zip, and then this splat operator, that makes it even more elegant, and I think even more efficient, because we have two for loops nested, so this is not very efficient. If you see two nested for loops, here I have one for loop, so it will be more efficient, I'm sure. But we'll save that for a later day. I found this on the same LeetCode. It's not my code. It's one of the upvoted responses or upvoted solutions on LeetCode. So we'll stop here. I'll hang around for 5 minutes. I'm on the Slack channel also. Please send me your feedback. Definitely, there's a GitHub. Oh, good. So the moderators have already posted the GitHub link. So you should see the lab on GitHub. You should see the recording on YouTube. And you can find us on Slack. So hopefully that should cover everything I wanted to. So thanks for joining, and I'll be here for 5 more minutes.